Hello friends, welcome to my channel. Let's have a look at problem 737, Sentence Similarity II. So this problem requires to judge if two sentences, sentence 1 and sentence 2, are similar. So the similarity of the words are inherited from the similarity pairs given by the problem statement. So the constraints about this problem are given here, so we will not go through it here. So let's look at the method directly. So the solution here is based on disjoint set data structure or union find. So the idea is very straightforward. So the word similarity relation actually forms an equivalent relationship. So a relation is equivalent relationship in the sense of mathematics or set theoretical analysis is that it's reflexive, it's symmetric, and it's transitive. Reflexive means that a word is similar to itself. So let's take this for granted. And symmetric means if a word is similar to another word, then another word is also similar to this word. So transitive means if word A is similar to word B, and word B is similar to word C, then word A and C are similar. So as such, actually we could partition the words that come into play into clusters. So within each cluster, the words are similar to one another. So that's the main idea for the solution we're going to share. So the procedure is as follows. So we're going to check the sentence length. So if they are not equal, we're going to return false. And otherwise, we're going to iterate for each index and check if the corresponding pair of words in the two sentences are in the same clusters. In other words, if they are similar. If not, we're going to return false. And finally, out of this loop, if nothing is returned, we're going to return true. So that's the main procedure. So let's have a quick walkthrough for this for a specific example. For example, if sentence 1 is given by I love Leetcode, and sentence 2 is given by I love One Piece. So the similarity relation is given by the similarity pairs here. So here, given this similarity pairs, so the cluster formed is actually a very special cluster. That's the whole cluster. So because manga is similar to One Piece, and One Piece and manga is also so One Piece is manga is also similar to anime, and anime similar to platform similar to Leetcode. So yeah, that's the whole cluster. That's the 5 words form a cluster. And then after we check the length and then compare the word pairs at each index, we found that either the pair are equal or identical words, or they are belonging to the same cluster, meaning that they are similar. So we return true in this example. So this is a very quick walkthrough. So with that said, let's look at some suggestions. So actually we can formulate this problem also in a graph. Then we can do traversal, either breadth first search or depth first search, to find connected components, then solve the problem. So in graph, the connected component is corresponding to the cluster here. So then another thing is that we can encourage to check the playlist in the channel for other use cases of disjoint set and union find method, and the different implementations aligned to specific problems. So with that said, let's have a look at the solution code to this problem. So first, I'm going to make some preparation. So here, I'm going to implement the disjoint set data structure within the function. So I would first get the full set of words that come into play. So this actually has 3 sources. One is from sentence 1, the other is from sentence 2, and similarly it can also from similar pair. So let's do it in a very brute force way. Full set, let's see, it's a set. Then I want to add the possible words to the full set. So for word in sentence 1, so I'm going to add the word to the full set. So similarly, we'll do for sentence 2. Let's do this. Let's copy this one and make a modification for this. And then for safety, maybe we can also add the word of similarity pairs to the full set. So for word 1, word 2 in similar pairs. So we're going to enlarge the set by unit operation. So it's word 1, word 2. So this forms the full set that we're going to use. Next, basically, is an initialization. So for the use of union find. So for this, I'm going to initialize 2 dictionaries. One is root and one is rex. The root will store the node and the parent relationship, and rank will store the node and rank. So here the rank will be the cluster size. So let's do this word initialization, word for word in full set. So initially a word has parents as itself. So and a word have cluster size and 1. A single word cluster, right? Word in full set. So this finished the initialization. So next basically is the implementation of the find and union functions. So let's first implement the find. That's actually very straightforward. So we are going to set a result to word. So I'm going to check in a while loop if result is not equal to the roots of result. If so, we're going to iterate. We set result to its roots. So this after we exit the while loop, we're going to have a state that is result equals the root result. Then we're going to return the result. So in order to accelerate a little bit, so we can actually point each of the nodes in the path to the final root. So for this, actually we can do something like this. We can set the roots of result to be the roots of the result. So if you like, you can apply more roots here, but this will do the job. So this is the find function. So next we are going to implement the union function. So word 1 and word 2. So for this, basically we are going to merge the 2 words if they are not in the same cluster based on the rank. So let's first track their roots. So they're going to use the find method, word 1 find word 2. Then if R1 does not equals R2, meaning that they are not in the same cluster, so we are going to track the rank information and decide how to merge. If rex R1 is greater or equal than rex R2, then we're going to set the roots of R2 to be R1, and then we're going to increment the rank of R1 by that of R2. So this is the routine. Otherwise, we're going to do the same thing but in the reverse direction. Let's copy this and do some modifications. Let's set root R1 to be R2 and then increment the rank of R2 by that of R1. So that's the full hyperfunction here. So next we are ready to make connections to the current problem and do the real work. So for this, basically we want to form the clusters based on the similarity relations inherited from the similar pairs. So basically it's a for loop for word 1, word 2 in similar pairs. So we are going to union them. So that's the main thing we have done. So next we're going to prepare the return. So first we're going to check the length of the sentences. If the 2 sentences have different lengths, so they are not similar, we're going to return false. So first, if length sentence 1 does not equal to length sentence 2, we're going to return false. So otherwise, we are going to compare the word pairs corresponding to each index. Basically, it's a for loop for word 1, word 2 in zip, sentence 1, sentence 2. So we want to check if they have the same root. In other words, if they are in the same cluster. So if find w1 equals find w2. So if they are not equal, so we are going to return false. Return false. So after the for loop, if nothing has returned, we're going to return true. In other words, the two sentences are similar. So that's the full solution code for this problem. We actually follow the procedure here. And let's do a special case check. Yeah, it passes a special case. Now let's do a generic case check. Yeah, it passes the generic case. For this video and this solution, so we actually implemented the disjoint set data structure within this function. So we first get the full set of words, and then we do the initialization. And after that, we implement the two functions, find and unit. And finally, we make connection with the current problem. And lastly, we prepare the output. So with that said, I guess that's it about this video. Thank you very much.